Today we're going to look at bisectors of a triangle. So for the warm-up, they want us to sketch a triangle and label it ABC. They also want to draw and label a perpendicular bisector, segment BD. So remember, a perpendicular bisector does two things. It creates right angles, and it creates two congruent segments. So we would draw in BD, and we would mark it with a right angle, or you could even mark it with two right angles, and two congruent segments, indicating that BD is the perpendicular bisector of the triangle. So today we're going to learn some properties of perpendicular and angle bisectors in a triangle. First of all, we'll talk about the distance. Anytime you're finding the distance from one point to a line, it can't just be any segment that's drawn. It has to be a perpendicular segment. So the distance from a point to a line is the length of a perpendicular segment from a point to that line. The length of a perpendicular segment from a point to a line. So looking at our examples here, you can see that yes, this is a perpendicular distance. This is, yes, representing the distance. It's the shortest distance, and that's why it's called the distance. You can notice that this segment is not perpendicular, so this is not representing the distance. Two theorems here on the front. The first one is the perpendicular bisector theorem. It says if a point is on the perpendicular bisector of a segment, so if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. Equidistant as a word means equal distance from either endpoint. So it's telling us that if this point is on the perpendicular bisector, then it is equal distances from the two endpoints. So you can actually go ahead and draw in two segments connecting those and mark them as being congruent. This point has to be equal distance or equidistant from the two endpoints. Probably should put this over here. The converse, we know the converse, which is the hypothesis and the conclusion. So it says, if a point is equidistant, so if you know that a point is equal distances from two endpoints, then you'll know that this point must be on the perpendicular bisector. So you would be able to conclude that it's on the perpendicular bisector. Most of these theorems are not used in proofs, they're rather used in problem solving, finding a segment or an angle measurement. So we're going to use this theorem to find the length of CA and DB. So first of all, you want to notice, what is the perpendicular bisector? Is CD the perpendicular bisector, or is AB the perpendicular bisector? Which one is it? CD, that's right. So the theorem says if a point is on the perpendicular bisector, then it has to be equal distances from the two endpoints. So we can add in markings that AC is congruent to CM by this theorem. We can also notice that point D is on the perpendicular bisector, which would mean that AC is congruent to DB. Once we've added those markings, we can see that this one's labeled 5, therefore CA, or AC, has to be 5 centimeters, and 6 and 6, so GB. On the back, we have some angle bisectors. So remember, an angle bisector in a triangle is a segment that bisects one of the angles, cuts it into two congruent angles. How many angle bisectors does a triangle have? What do we think? There should be 3. That's right. There are 3. Here's one. Here's another. And here's the other. I've already sketched them in my picture. Now we have our angle bisector theorem. It says, if a point is on the bisector of an angle, so if a point is on the angle bisector, then it has to be equidistant from the two sides. So then it has to be equal distances, you can see the markings, away from each side. Remember, distances are shown usually with a perpendicular segment to that line. The converse theorem says, if a point is in the interior of an angle and it is equidistant from the sides, then it must be on the angle bisector. So then, if this is occurring, you can conclude this has to be an angle bisector. Example 2, find X, FA, and FB. So the first thing we want to do here is identify the angle bisector. For those of you that like highlighters or markers, you might want to highlight it. This is the angle bisector. It's cutting the angle into two congruent parts. So we know that any point by the angle bisector theorem, this point has to be equidistant from the two sides. So we added markings. AF has to be congruent to FE by this theorem. If they're congruent, then they are equivalent in length. So we would set 5x equal to 2x plus 24 and solve. We should get x is 8. Then all we have to do is plug that back in to get FA is 40. And this should also be 40, but let's verify. And this blank says a point on an angle bisector is equidistant from the sides. So kind of just restating the theorem. See if you guys can find the answers to the closure. I'm going to pause the video. Okay, when you're ready to see the answers, I'm going to share those with you, and you want to be really careful with number 1. Remember, the first step is to identify the perpendicular bisector. The perpendicular bisector in this problem is CD, not AB. CD is the perpendicular bisector. So the theorem says any point that lies on the perpendicular bisector is equidistant. So we should have a marking here and here. And we should have a marking here and here. 2 markings there and there. So we should be getting that if this is 17, this side is 17. You can see this was 15. And if this is 16, this is 16. That's what we should be answering. DB is 16. The biggest mistake is that you guys will assume that the top two are congruent and the bottom two are. That's not always true if the perpendicular bisector is going sideways. When you look at it sideways, these two are the same and these two are the same. Okay, the next one, we should see that this point is on the angle bisector, therefore its congruent parts would be G and GC, setting those equal. We should get x equals 6. The homework for the weekend is the 5.2 worksheet.